So this is another application question from Unit 1-2, boxes D and E, and this is sort of the second major type of question you're going to encounter, where you've got some sort of a mass that is suspended in midair, and what you're asked to find are the tensions in the ropes that are holding this up. So what we've got here is an object with a mass of 51 kilograms suspended from two ropes attached to a ceiling 1.5 meters apart. So that's where the attachment points of those two ropes are. And the other end of each rope is attached to a point on the top of the object. The ropes, and we're given the lengths of the ropes here. They're 1 meter and 1.3 meters long. And what we want to find, again, is the tension in each rope. So when we're asked to calculate tension, usually all they want is the magnitude of the tension. So what we're going to do here is we're going to draw two diagrams. One is going to show sort of the physical picture of what this system would look like, and I'll just call that the diagram. And using that diagram, we're going to draw a second diagram over here where we show how the forces that are involved in this question are sort of organized. And it's this force diagram over here that we're actually going to use to solve the question, but we're going to need information from our physical diagram in order to do that. So we've got a ceiling here. We'll just say this is our ceiling, and two attachment points for our ropes here, which are 1.5 meters apart. And then we've got our two ropes hanging down like this, which are both attached to some object here, which has a mass of 51 kilograms. And we are told the lengths of these two ropes, 1 meter and 1.3 meters. So what we know is that there is a force on exerted by that gravity exerts on this object pulling down. So we'll call this the force of gravity. And we know how to calculate that force of gravity. It's just 9.8 times the mass, which is 51. So we've got gravity pulling down with about 500 newtons. And because this thing isn't moving, it's held suspended, that gravitational force has to be balanced by other forces. And the forces that are balancing it are the tensions in these ropes. So I'm going to call these things T1 and T2 for our two tensions. So if we take these forces and we put them together, what has to happen is, let's go over to our force diagram over here. We have a gravitational force pulling down like this, which is 500 newtons. Because this thing isn't moving, we have to have an equilibrant, or a force that balances those 500 newtons. So this has got to be 500 newtons to balance our gravitational force. And these two vectors should be the same length. I just haven't drawn them very nicely. Now, where does this equilibrant come from? Well, it's made up by adding together T1 and T2. So that's what our force diagram looks like. T1 and T2 have to add up to a force of 500 newtons. Now, what we're missing on our force diagram are any kind of angles. We're going to need angles in order to solve this question. So where we get our angles is from this physical diagram that we have over here. So I'm going to label this angle in here X, and this angle in here as Y. And of course, if we sort of draw horizontal like this, from the little Z pattern, this is going to be Y, and this is going to be Y as well. Now, how do those correspond to angles on our force diagram? Well, let's pull in one of these little coordinate axes here, like that. And then let's take a look. X is between the head of T1 and the horizontal. So if I go to the head of T1 and the horizontal, that's going to be X right in there. Y is in between the head of T2 and the horizontal. So that's going to be, if I grab another one of these things and put it up at the head of T2, Y is going to be right up in there. Okay, so if we can find x and y from this diagram, we can put them over here into our force diagram and then start working out what what angles we need to solve for the tensions T1 and T2. So how can we get x and y from this picture? Well, we're going to use cosine law because we've got 1, 2, 3 sides in our triangle, so we can solve for any angle we want. So cosine x is going to be, let's see, it's the one sides on either side, so 1.0 plus 1.3 minus 1.5, all of those are squared, divided by 2 times 1.0, 1.3. Nope, and I've done that incorrectly. X has got to be, let's fix that. We want, on either side of x is 1.0 and 1.5, okay, minus 1.3 squared divided by 2 times 1.0 times 1.5. So we work all of this out, and we get that angle x has got to be 58.67 degrees. And we can do the same sort of thing for angle y here. Cosine of angle y, let's try to get this one right the first time. We're going to have 1.5 squared plus 1.3 squared minus 1.0 squared divided by 2 times 1.5 times 1.3. And we work all this out, and we get that angle y is going to be 41.075 degrees. So once we have x and y, we can start working out what these other angles are going to be inside of our triangle in here. So we already know what x is. We've got right angles in here and in here, so we can work out this angle in here is just going to be 90 minus y, so this is going to be 48.925 degrees. This guy down here is going to be 90 degrees minus x, so it's going to end up being 31.33 degrees. Okay. Now we have all the information we need to start solving our triangle. So we want to solve for the magnitudes of T1 and T2. What we have is we have the angle opposite T2, and we have, well, let's work out what this angle is opposite our 500. So if this is y up there by the little z pattern, that one has to be y in here. So the angle in between these two has got to be x plus y. So x plus y is going to give us 99.75 degrees. So that's the angle opposite our 500 Newton force. So let's set up our sine law here and start solving here. So the magnitude of tension 1 divided by the sine of the angle opposite is going to be sine 48.925. That's all going to be equal to our 500 Newton force divided by the sine of that angle we just calculated, 99.75. So we solve this, we get the magnitude of T1 is going to be 382.45 newtons. And a similar sort of analysis gets us the magnitude of tension 2. Sine of the angle opposite is 31.33 degrees. And again, we're going to have 500 divided by the sine of the angle opposite it, which is again 99.75 degrees. And solving this, we get the magnitude of tension 2 is going to be 263.79 newtons. Okay? And in these tension questions, you only need to solve for the magnitude. You don't have to worry about the direction. So these are vectors here and here. And so we're done.